Hi everyone, welcome to G World of AKT Physics. Today we will discuss the Model 7, the basic model of electrostatic. If you look at these questions, this is a question of electrostatic with circular motions. What is the question is asking? How much minimum velocity is required to complete a circular motions vertically? Look at this scenario. A charged ball of charge Q2 having mass m is here. Exactly at the center of the circle, a charge Q1 has placed. A string is between Q1 and Q2 and the charged ball attached to this string. The question is asking how much minimum velocity, that u minimum, I must provide to this charged ball so that it can make a complete circular motions vertically. If you're trying to solve these questions, we must use the concept. Look at the topmost point. At this topmost point, you are using the concept that tension at this topmost point must be minimum, and we make it to be equals to 0. First, look at what are the forces that exist at this topmost point. I am making this topmost point. If I assume this is as A point and this is as B point, look at the forces have been existed. This is weight mg and tension at this point, it is downward, tension is downward, and this is positive charge. This Q2 charge now here, so Q1 Q2, so electrostatic repulsion will be exist like this, and it is making a circular motions, and we are observing in the rotating frame, in this charged frame we are observing, so centrifugal forces mv square by r, it will be radially outward at this point. So if I make the balance situations, can I say T plus mg is equals to F electrostatic plus mv square upon r? Yes, I can write like this. So T, I can write this is as Fe plus mv square by r minus mg. And I will substitute this Coulombic force value. What is the Coulombic force value? This is K Q1 Q2 upon R square plus mv square by r minus mg. I hope the scenario is clear to everyone. If I make the tension is minimum, which is equals to 0, so can I get 0 equals to K Q1 Q2 upon R square plus mv square by r minus mg. I am using the conditions tension at the topmost point is minimum. So here I can say this mv square by r, I'll make this side. So what is the things have been coming? This is mg minus k q1 q2 upon r square. So what is the things have been coming? This mv square equals to mgr minus k q1 q2 upon r. I hope these mathematical calculations one can easily understand these things. Not a big deal at all. So what I am using the concept up to this scenario, I am writing what are the forces have been here. mg is downward, tension also downward at this point, strings tension is downward, Coulombic repulsive forces due to Q1 and Q2, it goes like this, and centrifugal forces have been like this. So I am simply writing T plus mg equals to electrostatic force plus mv square by r. This T is these things, and I am making the concept that tension is minimum. So using that, I concluded with this result. Please add this result as an equation 1. Now we are using another concept that is called energy conservations. Very important, energy conservations. What is energy conservations principle we are using? One can say the work done by all forces equals to change in kinetic energy. I am using the concept that work done by all forces equals to change in kinetic energy. If you observe carefully, here work done due to tension plus work done due to mg plus work done due to electrostatic equals to change in kinetic energy. Can I say this is as K final minus K initial? Each and every instant, if you observe this work done by the tension, suppose I will consider this scenario, tension is like this and displacement is like this. So what is the angle between this tension and displacement? I can say the angle is 90 degree. So work done due to tension, force, this is tension is a force and displacement is like this. So each and every instant I will say the angle is 90 degree. So force dot displacement giving rise to 0. So work done by the tension is 0. Work done by the electrostatic, if you observe carefully, this is Q1, this is Q2. Any instant I am looking, if you observe any instant, if you look at this scenario, the electrostatic force will be also like this. The electrostatic is like this. And what will happen? This is your force and this is your displacement. Force and displacement angle also 90 degree. Due to this, the work done due to electrostatic also 0. And one thing is exists, that work done due to mg. Here at this instant, observe, if you observe, this is mg is downward. Each and every instant, if you observe, this mg is downward. And how much height it goes? It goes to a maximum height of 2r. It goes to a maximum height, how much? I'll say this height it goes, because initially charge is here, now charge is here. So how much height it goes? 2r height, and mg is downward. That's why the force and displacement, you can call it, the angle is 180 degree. So I can write minus 2 mg r equals to K final minus K initial. K initial is what? How much minimum velocity I provide. This is the minimum velocity that I provide. And what is final velocity? Suppose at this instant I said my final velocity is v. At this instant I will say my final velocity, I call it to be v. So can I say this is K final, this is half mv square minus half mu minimum square. That the u minimum is required because I already mentioned mv square by r. So at this instant the centrifugal force is mv square by r. So that's why at this instant the velocity I have treated v, and this is the minimum velocity that I provide so that it can make a complete circular motions vertically. So little arrangement if I do, minus 4 mgr equals to mv square minus mu minimum square. So what is the answer? mv square is coming, that is mu minimum square minus 4 mgr. This is my equation 2. Look at these two equations. This is mv square equals to mgr minus kq1 q2 upon r square, and this is these things. Both the LHS are same, so I can compare these two equations. So what I'll be think will come out. This is mu minimum square minus 4 mgr equals to, this is mgr minus k q1 q2 upon r. So what is the thing is coming out? Making this is mu minimum square equals to 5 mgr minus k q1 q2 upon r. So u minimum equals to 5 gr minus k q1 q2 upon rm root over. Without any electrostatic, if you observe these things, for circular motions without any electrostatic force, we already know that the minimum velocity required in order to make a complete circular motions vertically, that is root over of 5gr. But here the things you observed, your u minimum has reduced by some, this additional thing is coming out, which is reduce this 5gr. This is very important result when you are observing this thing in electrostatic field, means due to charge field this value has little reduced. So let me summarize what are the things we did. The question is asking how much minimum velocity is required for this charge in order to make the circular motions vertically. We are just writing the tension at the topmost point, and we know at the topmost point the tension is minimum. Using that concept we are getting that equation 1. Again, the another principle that you use, that energy conservation principle, that is work done by all forces equals to change in kinetic energy. Here three forces we are looking into. One is tension, one is electrostatic, another one is work done by mg. Work done due to tension and electrostatic, it is 0, as forces and displacement are mutually perpendicular, and using this concept we are getting this equation 2. Both the LHS have same, so we are just making a small comparison. We are getting the u minimum value, which is 5gr minus kq1 q2 upon rm. I hope this scenario has cleared. This is a good question that can be framed using the concept of electrostatic as well as circular motions. Thank you everyone. Thank you for your watching.